Hello students, welcome back to this session of PW International Boards. Here I am to discuss with the next chapter for your subject chemistry with the paper code 0620. So as you all know that in this particular series we are taking out the chapters and in that we are including only the important concepts which are according to your upcoming exam series. So today we are going to discuss with the chapter metals. Now in this particular chapter, if I talk about metals, it is very easy to listen and to understand also that a very simple chapter. We know that what are the metals and what are non-metals and their properties and everything. But let's see that in this particular unit what all things we are going to discuss. And remember one thing more, that while discussing the important concepts of this particular unit, we are also going to take out the few, not very much, but few PYQs, that is the previous year questions. Okay, and if you want a detailed question discussion, then you can just follow us and look the previous year paper discussion which we are already doing. So let's see the topics which we are going to cover in this particular unit. So first we are going to talk about the general physical properties of the metals and non-metals. Then we are going to talk about the chemical properties of metals, and then uses. About the alloys we are going to look, and then we are going to look about the reactivity series, then reaction with water, reaction with dilute acid. So basically we are going to look about the chemical properties, alloys, reactivity series, reactions, and besides that we are also going to talk about the corrosion and the extraction. So let's see over here that what are metals. Now you all know that when we look at periodic table, in the case of the periodic table, you know that it is what? In that we are having the 118 known elements. Now from that 118 known elements, out of that 70 elements, that is the left side of your periodic table, is of the metals. Okay, so now when we are talking about the metals, so it means the basic type of the bonding in them is, we call them as a metallic bonding. And if we look the shared properties like the conductivity, malleability, they vary, and then we have the other properties like the density. Like for example, iron have very high density, but if I talk about the alkali metals, they have the low density. So these are the, like, density property is a varying property, but if I am going to talk about the conductivity, malleability, ductility, then these are the properties which are very common among the metals. Now looking towards the non-metals, non-metals are what? So now looking towards the non-metals, when we talk about the non-metals, it is basically the opposite side of the periodic table, and they have the diverse properties, and they form the simple molecular or the giant covalent structures. Like if I talk about the simple molecular, that is the hydrogen, like we represent the hydrogen as the H2, oxygen as the O2, N2, then we have the sulfur we have the S8, then we have the P4 for the phosphorus, and we have the certain covalent structures like in the case of the carbon. Now over here, remember one thing, that if I just make a rough sketch for the periodic table in order to remember the things. So let's see over here. This is a rough model I am making of a periodic table. Okay, somewhat like this, if you look, the periodic table looks like. So remember one thing, that in this particular, this left side is of the metals. Okay, and towards the right we have the non-metals, and in between from this particular region, if I look, this particular region consists of the metalloids. So this is a basic structure of the periodic table. Now moving ahead, we have the few general physical properties for the metals and non-metals. Like the first property is the thermal conductivity. Now when I am going to talk about the thermal conductivity, and let's discuss about the metals over here, that in the case of the metals, if you look that what it is. Generally we know that metals are very good conductor of the heat, and the reason behind it, that why they are the good conductor of heat, that is because of the delocalized electrons. Basically the conductivity is high due to the presence of the delocalized electrons. Why? Because when you are going to heat any metal substance, then what is going to happen, that delocalized electron is going to transfer. When it is going to transfer, then only the thermal conductivity is going to take place efficiently. For example, if we talk about the copper, aluminium, they are very good excellent conductor I should say, and they are used in the electrical wirings and heating sinks. So that is the reason, because in your theory paper we get sometimes a question like this, that what is responsible for the electrical conductance in the metals, and many students do the mistake also over here, because regarding the electrical conductance we get the two types of the question. One, in the case of the your ionic compounds, and one in the case of the metals. Now remember one thing, that when we are talking about the metals, in the metals the electrical conductance is responsible, or you can say the delocalized electrons are responsible for the electrical conductance in the case of the metals. Whereas when we are going to talk about the ionic compounds, in that the free electrons over there, which we are going to again called as or is the free ions, not the electrons I should say, the free ions are responsible for the conductance of the electricity. Over there we do not use a word electrons. Okay, so this point you have to remember. Coming to the next case is the this metals only about the electrical conductivity, that is the giant metallic lattice structure of metals means that they are the good conductors of heat. Now if you look over here, we have taken a one rod, and in this rod we just start heating it from the one end. Now what is going to happen, like just over here, if you imagine that this is a particular, my pen, just imagine it is a rod. Now when I am going to start heating this rod from this particular end, so what is going to happen, that over here whatever the electrons are there, they are going to start vibrating, and when they are going to start vibrating, slowly they are going to start on the vibration, they are going to start transferring, and slowly this rod is going to start heating it up to the end. It is not like this that from the starting only your rod from this particular end is also going to heat up. No, initially it is going to heat up from here only, and if you will touch at this end, it is going to be the colder region only. But slowly when you are going to continuously heat it, what is going to happen, the electrons are going to start vibrating, because you can say that they are going to attain a kinetic energy, and due to which they are going to start vibrating and move towards this opposite end, and the complete rod gets heated up. Talking about the non-metals, in the case of the non-metals typically have the lower thermal conductivity compared to metals. And why non-metals are the bad conductors, or you can say that they have the lower thermal conductivity? Because they do not have the delocalized electrons, or you can say the free electrons that contribute to the thermal conduction. For example, we have the wood, plastics, they have the lower conductivity. Coming to the electrical conductivity, again the metals are the good conductors of electricity, and that is also due to the presence of the free electrons, which can move easily under the influence of the electric field. Okay, so that is the reason we use the wires from copper wires we use. And why? Because the electrical conductance of the copper is very good. So like over here we have taken the example of the copper and silver. They are widely used in the electrical conductivity wirings and the electronics. Okay, although we prefer the copper because of the cost effectiveness, because if you are going to use a silver wire or the gold wire, even the gold conductivity is also very good, then it is going to be very high in the cost. So that is the reason we prefer the copper over here, but the conductance of this silver and gold is very good too. So over here, if you look, what happens that when you are going to provide the electric current to these metals, so what is going to happen, the electrons over here, or you can say the free electrons, I should say, they start vibrating, and due to that vibration only the conductance takes place. Same case like the thermal conductivity. Coming to the non-metals, non-metals have the poor electrical conductivity. So why it is poor electrical conductivity they have? Because of they lack the free electrons and do not conduct the electricity well. So for example, if you have ever noticed, like if I talk about the wire which is used for our household work, also the wiring of our house or whatever the electrical appliance, the metal is always covered with something plastic, something you can say rubber or the plastic. Why? Because they are the bad conductor of electricity. If your wire is going to be naked, it is not going to be covered with that particular thing, then what is going to happen? There will be the electric current always. So rubber, glass, they are the electrical insulators and they used to prevent the electric current to flow. Then malleability and ductility. Now first of all, let's understand that what is the meaning of the term malleability and the ductility. When we are talking about the term malleability, malleability means that if you are having any metal and when you are going to beat it with the help of the hammer, what is going to happen? It is going to convert into a thin sheet. Whereas when we are using a word ductile, ductile means that if you are having any metal and you just stretch it, so you can stretch it out into a thin wires. So basically malleability refers to the ability to be hammered into the thin sheets without breaking, whereas ductility is refer to the ability to be drawn into the thin wires. Okay. Now coming to the metals. For example, if we talk about the gold and aluminium, they are highly malleable and ductile, used in jewelry and wiring. And the layers of the metal atoms in their structure means they can slide over each other and when the force is applied. Basically, if I talk about the reason behind that, why the metals are able to means we are able they are have the property of the malleability and ductility. The reason is what? Because when you are going to apply a much more force, basically you are applying a force only when you are hammering it or you are stretching it into a thin wires. So what happened? They have a slide over structure. The electrons over there, they can just slide over. Why? Because they are the free electrons. Because of that slide over structure, these two properties exist in the metals. In the case of non-metals, they are brittle and not malleable or ductile. They tend to shatter rather than deform under pressure. For example, the sulfur and carbon in their pure form, they are brittle and lack malleability or ductility. Like if I talk about the any of the non-metal surface, any of the non-metal object, when you are going to hammer it, it is going to break, isn't it? If you want to stretch it, it is going to shatter down out. Why? Because they do not have the any sort of the free electrons, I should say. Another point over here, that their structure is a brittle. So when you are going to hammer it or you are going to stretch it, what is going to happen? It is just going to shatter down out rather than converting into a thin sheet or the wire. Coming to the melting and boiling points property, metals have high melting points and boiling points. And these points vary depending on metal but are generally higher compared to the non-metals. For example, we have the tungsten. Tungsten has a very high melting point of 3422 degrees centigrade, which is used in high temperature applications. Similarly, non-metals have the lower melting and boiling points compared to the metals, and they exist in the various states like the solid, liquid and gases at room temperature and pressure. So like oxygen melts at minus 218 in 0.79 degrees centigrade and it boils at minus 182.96 degrees centigrade, existing as a gas at the room temperature. Then metals. Now What is the reason behind that metals have the high melting point or the boiling point? Metals have the crystalline structure features. Crystalline structure means that they are very closely packed in a regular pattern they have. Like for example, they have the face centered structure, or they can have the your BCC type of the structure. Such structures they have. And metal, because of the presence of the metallic bonding, it allows you to, for the delocalized electrons, leading to high conductivity and mechanical strength. So basically its structure is responsible for its conductivity or the mechanical strength, that why the metals are so hard in the nature. Non-metals. Non-metals varies widely. Simple molecular structure, for example in the case of the hydrogen and oxygen, or the giant covalent structure, for example the carbon. Basically the diamond and graphite are the allotropes of the carbon. Like over here we have mentioned the structure of the diamond and graphite. If you look, their structure are what? They are covalently bonded. So bonding types determine properties like the hardness and conductivity, with the structures ranging from discrete molecules to extensive covalent network. For example, diamond, if I talk about, it is one of the hardest substance known. But graphite is not the hardest, it is very soft. Another point over here, because of the your graphite, if you look, say suppose we consider this carbon atom. So now this is being a carbon atom going to make a 4 bonds. Now each carbon atom is making over here, if you observe, 3 bonds only, means 1 electron is free over here. So because of that 1 electron free over here, the graphite is the conductor in nature. And that is the reason we use it in the electrolysis process. But if you look in the case of diamond, like this, considering this as the carbon, so 1 bond, 2nd bond, 3rd bond, 4th bond, so all the electrons are packed over here. So that's why what is happening, its structure is compact, and because of that compact structure, it do not conduct the electricity, or you can say it cannot have the thermal conductivity. Now next comes the reactivity of metals. Basically, if you look the periodic table, the complete periodic table, if you are going to look, there is the noticeable reactivity among the metals, and they follow a certain trends. Like for example, group 1 is known as the alkali metal, and for instance becomes more reactive with water as you descend the group. So reactivity of metal, we can say, is not going to be same for all, and reactivity series govern in this particular process, or you can say the process of the reactivity. So over here, coming to this only, now the question comes that what is the reactivity series? This reactivity series, actually we have to remember, we have to learn, I should say, because it is very important to solve the question. So I just make a reactivity series over here. So it is what? Basically we have a sequence of the potassium, sodium, calcium, so on, like this up to your noble metals. So for this particular reactivity series, I just provide you a mnemonic over here in order to learn it, and I hope you are going to enjoy it. So let's please stop calling me a careless zebra. Instead try, because of the less space, I am using a right hand side over here. Try learning how copper saves gold. Now in this particular reactivity series, you are going to consider the P over here, S, Cal, M, A, Car, Z, I, T, Le, H, S and G. And another point over here, what is that? That when you are moving top to bottom, okay, top to bottom when you are moving, what is happening? The reactivity decreases. Means your gold is going to be a least reactive in the nature, and this is going to be your most reactive in the nature. Okay, so now I tell you this. Please stands for the potassium. Stop stands for the sodium. Calling is for the calcium. Me for the magnesium. A for the aluminium. Careless for the carbon. Zebra for the zinc. Instead for the iron. Try for the tin. Learning for the lead. How for the hydrogen. And then you are going to have copper. Save for the silver, and gold is going to be gold. Okay, so the mnemonic for learning this particular reactivity series is what? Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So in this manner, you can just learn the reactivity series, and it is important also because on the basis of this reactivity series, we get the question whether it is our MCQ paper or the theory paper, whatever. Okay, so I hope you are going to enjoy in learning this through this particular method. So let's move ahead. Over here we have the reactions with the dilute acid. Now when we are talking about the reactions with the dilute acid, metals react with dilute acids to produce salt and hydrogen gas. Like whatever the metal you are going to take, like over here I have taken the example of the zinc. When it is going to react with the HCl, it is going to provide the ZnCl2 and H2. Like over here, say suppose if I take a magnesium, okay, and I make it react with the acid. So I am going to get a magnesium sulfate and hydrogen gas is going to liberate. So the basic reaction is what? That metal plus acid is compulsory going to give you the salt and the hydrogen gas. Now from this particular point we get a question about the reactivity, that who is going to be the least reactive or the most reactive over here. Metals react differently with the water based on their reactivity. For example, if you are going to take a cold water, so with the cold water, only very reactive metals are going to react, like the sodium reacts with the water with explosion. If you are going to place a sodium in the water, you are going to have a explosion. Okay, like over here, I just tried to show you over here that what sort of the explosion you are going to get in the beaker. Why? Because it is going to form the hydrogen gas and the hydroxide of that particular metal. Now the metal for the reacting with the cold water, the metal should be reactive enough in the nature. Now, like over here we have taken the example of the calcium and magnesium. If you are going to make react calcium with the cold water, it is going to float in water as the evolved hydrogen sticks to the porous calcium. So it is going to form a calcium hydroxide and the hydrogen gas. The moderately reactive metals like the magnesium, zinc, iron, they react very slowly with the water, and they however react more rapidly with the steam. Like if you are going to take the iron and you are going to take a steam, then it is going to react very rapidly to form the iron oxide and the hydrogen gas. Aluminium. if I talk about the steam or the hot water, aluminum has a protective oxide layer which prevents further reaction with the steam. If a metal reacts with cold water, a metal hydroxide and the hydrogen gas is being formed. If metal reacts only with the steam, then metal oxide is being formed over there. Okay. Then metal reacts with oxygen to form the metal oxides. Like if you are going to have a high reactive metal, for example, the potassium, sodium, they are going to form their corresponding oxide on reaction with the oxygen. Okay. And they burn very strongly to form the oxide. Then if you are going to have a less reactive metals, they react less vigorously but they form the oxide. Aluminium and zinc, they develop a protective layer preventing further oxidation. Like say suppose if I want to make a reaction of the aluminium, first I require to remove the oxide layer from the surface of the aluminium. Then it is going to show a reaction. But if I am not going to remove the oxide layer, then that particular oxide layer is going to work as the protective layer for the aluminium. So, talking about the properties or you can say uses, basically if I talk about our examination point of view, because you know that it is a complete chapter we are going to discuss in this particular lecture. So, I have kept only the important topics according to the exam. So, we get one type of the question from the uses of the metals. Now, in the uses of metals, if I am going through it, then there are so many uses. But over here, we are going to have only the uses of the aluminium and copper. I am going to discuss. The reason being is what? Because in examination papers, we are going to ask with the aluminium uses at the first priority, and the second is going to be the copper. So let's talk about the aluminium. Now, aluminium is what? It is very light in weight. Its strength is very good, which provides a structural integrity, and it is a good electrical conductor. So because of these three properties, that is used at many places. And one more property is over there, that is, it is what? Resistance towards corrosion. So if I look application, now aluminium is what? It is a metal. So it is having a property of the malleability. Because of the property of the malleability and a high melting point, it is a very good thermal conductor, and that is the reason we use it as the utensils. Aerospace. Now we just came to know that it is what? It is a lightweight. So alloys with metal like the copper for the aircraft construction. Why? Because of the strength and the lightweight properties. And the world's first supersonic passenger jet Concorde was built out of an alloy containing over 90% aluminium. It is only for your knowledge. No question is going to come from here. Electrical transmission, preferred for the overhead power lines due to its excellent conductivity and corrosion resistance. Packaging industries, we use aluminum foil containers because they are resistant towards the corrosion from the natural acids, making them ideal for the food packing. Even, not even the food packing, if I talk about the medicines also, if you observe the strips which we get from the market for the medicine, they all are made up of the aluminum. Why? Because it is corrosion free, resistant to the corrosion. Then we use in the building materials also, like in the window frames and the external structure, due to its weather resistance and durability. Talking about the uses of copper. Now, copper is known for its distinctive color and is one of the least reactive metal in common use. Now, copper, you know that it is very good in conductance and it is least reactive. Because of its least reactivity, we use for the roofing purpose and for the water pipes. Like it is used for the water pipes, roofing materials due to its durability and resistance to the corrosion. Besides that, it develops a green layer of basic copper carbonate known as verdigris over time when exposed to the atmosphere. Electrical conductance, if we talk about the electrical conductance, it exhibits a very high electrical conductivity, making it ideal for the electrical applications. And high ductile property allow us to easily drawn into the thin wires. Now basically you know that copper is very good electrical conductor, and It is ductile also in the nature. So because of this property, we use it in making the electrical wirings of our household items, whatever the appliances we have, and then whatever the electrical circuits we are going to make, we use a copper in that case. Then copper we use as in the utensils also. Why? Because it provides a very good heat distribution and control and ensures even cooking and precise temperature adjustment. It is also naturally inhibits the bacterial growth and can last for the generations with proper care, making it both hygienic and sustainable. So that was all about the metals. Now, if I talk about, I just summarize in 2-3 lines about the metals and non-metals and about the question. The one question you can get over there, the difference between the metals and non-metals. Now, you are not going to get a question as a difference and write down the difference between the two. You are going to get a question like this, that write down any 3 physical properties of the metals or 3 physical properties of the non-metals, or which properties make non-metals differ from the metal, like this. The second question you can get from the use of the aluminium or the copper, and the third type of the question, which is very common type of the question, is on the basis of the reactivity series, that they are going to give you the certain reactions with the water, acid. Mostly they give the water and acid reactions only, not the oxygen, and they ask that which one is going to be the least reactive or which one is going to be the most reactive, or make their increasing or decreasing order. And you get a question in the MCQ type also and the theoretical paper also. Next part of this particular chapter, let's talk about the alloys. Now, what are alloys? Basically, alloys are what? They are the homogeneous mixtures. Now, these homogeneous mixtures are what? These homogeneous mixtures are of the metals, non-metals, or you can have the metals also. And these homogeneous mixtures, what they do? They enhance the property of the metal. So, basically, they are better than the metals, whatever the metal is going, the parent metal of that particular alloy. So, alloys are what? They are the mixture of the elements and typical metals designed to enhance specific properties for the practical applications. Like you can have the brass, bronze, stainless steel. These all are the alloys. Okay. Now, what are the advantages of the alloys? Basically, alloys improve upon the pure metals by modifying their inherent limitations. For example, the softness, the susceptibility to the corrosion. For example, if I talk about the rose gold, it is the alloy of the gold, silver and the copper. If we look the historical significance, human began using alloys with the meteoric iron, a naturally occurring mixture of the nickel and the iron. So basically the bronze sculpture we make, it is of that. Then bronze developed in the ancient cultures with the composition of 90% of copper and 10% tin remains valuable for its enduring properties. Then steel alloys, they enable visually appealing and durable structure designs combining aesthetics with robust functionality, and iron is alloyed with the carbon and other transition metals. Stainless steel alloyed with chromium and nickel resist corrosion due to its protective oxide layer. Solder, an alloy of tin and lead, boost a low melting point ideal for creating electrical connections. So here is a list of the some important alloys. That is, now over here we get a question, and we get a question not on the uses, but we get a question on the composition. For example, the brass. Brass is an alloy of the copper and zinc. Then bronze is an alloy of the copper and tin. Then steel is an alloy of the iron and carbon. Stainless steel is the alloy of the iron, chromium and nickel, and solder is the alloy of the tin lead. Now among this also, if I talk about the most common asked question is about the brass, And at second number, sometime you can have the stainless steel, and at third number is going to be the bronze. No question up to now is being asked from the mild steel or the solder. Now, this is for the extended student. If I talk about the structure of alloys or alloy formation, alloys combine metals or metals with non-metals where the atoms of the second element integrate into the crystal lattice. Basically, what happens that if I am going to have the two type of the metals, now what is going to happen? They are just going to combine along each other to form the alloy. So, that is the reason we are calling it as a homogeneous mixture. Now, this integration disrupts the regularity of the lattice structure of the main metal, and alloy is not a mixture of metal crystal regions, but it is a regular lattice of the atoms. So, understood over here? That says, suppose if this is the structure of the one metal, so the atoms of the another metal is going to come in between over here and they form a perfect regular lattice of that particular structure. Bonding in characteristics. Despite changes in structure, alloys maintain metallic bonding with the delocalized electrons, and they retain characteristics, physical properties such as malleability, ductility, electrical conductivity and thermal conductivity similar to those of the pure metals. So, metals vary in their reactivity, which influences how they react with other substances such as water and acids. And reactivity is determined by the factors like the atomic structure, ionization energy and electrode potential. So, the reactivity series ranks metals from highest to lowest reactivity, guiding prediction of their behavior in chemical reaction. And this reactivity series we have covered in the just now only in the previous slides, that if I am going to talk about top to bottom, then top to bottom if you are going to move, the reactivity decreases. Okay. So, the first case over here is what? Reaction with metals. So, reactive metals like the potassium, sodium and calcium react with cold water to form the metal hydroxides and release hydrogen gas. For example, if I take a potassium and make it react with the water, it provides us the potassium hydroxide and the hydrogen gas. Similarly, if you are going to take a sodium and you take a H2O, then it is going to give you a NaOH and hydrogen gas. Okay. Then reactive metals like the potassium, sodium, calcium react with cold water to form the metal hydroxides and release hydrogen gas. Just now we have seen the case of the sodium and water. Now over here, if I talk about the reaction with water and you observe this particular, the potassium is going to be the most reactive over here, and if you look the gold is going to be the least reactive over here, which we have already seen in the reactivity series. Now when the metal reacts with dilute hydrochloric acid, hydrogen gas and metal chlorides are produced. So basically, for example, the zinc reacting with the HCl, it is going to provide a ZnCl2 and hydrogen gas. Then reaction with the dilute acid, if I talk about, if you are going to take a dilute acid, then hydrogen gas is going to produce over there, and whatever the salt over there is going to be, that is means if you are going to take the HCl, it is going to provide a metal chloride. If you are going to take a H2SO4, it is going to provide a sulfates. If you are going to provide a HNO3, then it is going to produce a nitric acid. Now, next is the application of reactivity series is where that metal extraction. Whatever the metals we have, that we get, that is not in the pure form, isn't it? We require to extract them. Now, for extracting them, we require to apply the several methods for the extraction. Now, that methods are also going to be on the basis of the reactivity series. Like just now we have seen whatever the reaction with the acids or with the water, they all are on the basis of the reactivity series. Similarly, over here also, like the extraction of iron from iron oxide using carbon in a blast furnace takes place. So, that is based on the reactivity of the metals. Electroplating. It utilizes the reactivity series to selectively coat objects with a layer of the metal through electrolysis. For example, we plate a nickel to enhance the corrosion resistance of the steel. Then alloy formation. Now it is not like this that we can combine any two metals together. It is on the basis of their reactivity only. For example, that when we combine a metals to create the alloys with desired properties, for example, the strength, corrosion resistance, so that is completely on the basis of their reactivity. Like in the case of the bronze, if you talk about, in the case of the bronze, we combine Cu and Sn. So similarly, in the case of the brass, we combine the Cu and Zn, means the copper and tin and copper and zinc over here to make an alloy. Now, it is not like this that we can take any of the metal and we can combine. That is going to be on the basis of their reactivity only. So, here is the summary of your about the reactivity series. If you look, the reactivity series is what? Potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, hydrogen, copper, silver and gold. If I talk about the reaction with dilute acid, the whatever the you can say the highly reactive metals, they are going to produce the hydrogen and they over here. And if you are going to come down, they are not going to react with the dilute acid. If I talk about the reaction with air or the oxygen, they burn with very brightly and vigorously, the one which are the highly reactive. But as you are going to move down, they are going to burn to form an oxide with decreasing vigor. And moving more down, they react slowly, and at the end of the reactivity series, they do not react. Similarly, in the case of the reaction with water, they produce the hydrogen gas, the one which are highly reactive, and slowly moving down, they do not react with the cold water, but they react with the steam, but in a decreasing manner. And moving completely down, they do not react even with the cold water or with the steam. Then if I talk about the extraction, the highly reactive metal, they are sorry, they are difficult to extract. And if I talk about difficult to extract, but if I come to the mild reactive, then it is quite easy to extract. And if I talk about the unreactive, or you can say very less reactive, generally because they are unreactive, so we get them in a pure form only. Okay, so basically what happens, that if you are moving top to down over here, the reactivity series, in the case of reactivity series, the reactivity decreases. Okay, now aluminum reacts very readily with the oxygen in the air over here, but a protective oxide layer is formed on its surface, and because of which it prevents any further reaction over here. In the case of aluminum, it is. Next thing comes, that is corrosion. Now, when we are talking about the corrosion, corrosion means what? Corrosion refers to a chemical attack on the metal. Now, in this particular case, what happens? Corrosion is basically a chemical attack on the metal and alloys by substances like oxygen and water. Now, from this corrosion also we get a different type of the question that they can ask, that name the process which takes place on the metal, or which something like that. They give a indirect definition, or sometimes they give a test tube, and in that they ask that tell which iron nail is going to corrode first. So such type of the question we get from here. So reactivity and metal behavior. Metals higher in the reactivity series corrode more quickly. For example, sodium and potassium corrode rapidly if not stored under oil. Remember one thing, that because the sodium is a very reactive metal, that's why we always store it in a paraffin or in a oil in order to make a surface on that. So that, like if I am going to take a paraffin, it is going to make a cover on that in order to prevent it to come in contact with the air or the water. While magnesium and calcium and aluminum form the protective oxide layer. Specific metal. Copper turns brown and then green due to oxidation and environmental exposure. If you have ever noticed, whatever the copper utensils we have in our house, they on exposure to the air, or you can say on exposure to the atmosphere with time, they get a greenish layer over there. Although we can just remove it by washing it properly or taking care of it properly, but they form the greenish layer. Similarly, if I talk about the gold and platinum, they are highly unreactive and they do not corrode over the time, and this is the reason that we prefer the jewelry of the gold and the silver. Corrosion of iron through a redox reaction takes place where iron oxidizes in the presence of the oxygen and water, forming the rust. For example, FeO2 plus H2O, it gives us the 2Fe2O3 x H2O. So this is the formula for the rust. Now, corrosion of the iron. To facilitate the rust formation, we require the following conditions over there. That is, that if we want that iron should get rust, then we should have the presence of both the water and the oxygen and the surface availability, so that the iron and water can make a contact with that surface and it can corrode that particular surface of the iron. Like this over here, like if I'm not wrong, this particular same is over here, these 4 test tubes and such type of the question we got in the May-June series year 2024. Now over here, if you look, we are having the tube 1, tube 2, tube 3, tube 4. This is particularly experimental form, and in the one we kept a distilled water. Okay, in the second we kept a anhydrous calcium chloride. Now when I'm saying anhydrous calcium chloride, it is what? It is a drying agent. So whatever the moisture is going to there, it is going to absorb it. Then in the third layer, we used a water, but at the same time we used a oil layer also. And in the test tube 4, we use the water and oxygen. So now look, in the case of the tube 4, the iron is going to rust most over there. Why? Because we are using over there the pure oxygen, we are using the water, and we are not removing anything from there. Even in the case of the tube 1, if I talk about, that is particularly a control experiment. So if we are going to compare the second, third and fourth tube, then fourth tube iron is going to rust at first. Then it is not like this that we want to rust only or make our nails to rust, or the whatever the iron we have, we require to prevent that rusting also. So the first thing comes, that is the barrier protection. So now how we can make a barrier on the iron surface so it do not get rust, or you can say the prevent from the rust. So the first method is what? That we can do a painting. For example, the protects painting, if you are going to do it, protects the object like the ships and the gates, and it requires the regular maintenance as the paint layer can be damaged. This we have seen many times that whatever the vehicles and everything, we just paint the surface over there, and if the paint gets removed from there, the metal starts getting, the iron starts getting rust over there. So we require to do the regular maintenance of that. Then oiling and greasing. It forms a protective film on the machinery parts and needs a frequent reapplication again. Then plastic coatings. It is used on items like the refrigerators and garden chairs, and PVC is commonly used for the protection over here. Then electroplating. It coats iron or steel with the chromium or tin. Like tin cans, they use tin to prevent the rust, but damage to the coating can lead to the rusting. Then alloying. Mixing iron with other metals to form a protective oxide layer that prevents the further corrosion. For example, we use a chromium in the case of the stainless steel. Then galvanization, or you can say it is a sacrificial protecting method from the rusting. It is for the extended student, that is galvanization. Now basically it involves the dipping steel objects into the molten zinc, and zinc forms a thin reactive layer coating of the steel. Now, this zinc layer corrodes slowly, losing electrons to the iron and protecting it, and protection gets continues even if the zinc layer is scratched. So, basically zinc or magnesium bars are attached to ship over there and the oil rigs, and zinc is more reactive than iron, so it corrodes in preference to the iron. For example, over here if you look, that zinc and iron, if you look, zinc gets converted into a Zn2 plus and Fe2 plus gets converted into a Fe. Now, as long as zinc bars remain in contact with iron, they protect the structure from rusting, and zinc must be renewed when depleted. So, this also what? That once the zinc gets depleted, you require to put again the layer of the zinc on the iron in order to protect it. Now, the last part of this particular chapter comes, that is the extraction of the metal. Now, when we are talking about the extraction of metal, many primitive iron tools have been extracted, like made from the native iron found in meteoroids. Now, around 2500 BC, iron became more widely used as the people learned to extract it from the ores in larger quantities, using charcoal for the reduction. Now, an ore. What is ore? Ore is a naturally occurring mineral from which metals can be extracted, and most metals are too reactive to exist in their pure form in the earth's crust, and that is the reason that we require to extract them. So, they occur naturally in rocks as compound in ores, for example, the carbonates, oxides, sulfides, and often mixed with impurities. Like gold and silver, they are naturally found in their native form due to high chemical stability, and they resist reaction with water, air, and remaining unaltered. Now, what is the basic process if I talk about? Basically, the large lumps of the ore, they are crushed and they are just grounded. We just grind them and using a heavy machinery. And some ores, for example, the hematite ore with over 80% Fe2O3 are already fairly concentrated, while others like for the copper pyrites require a concentration before the extraction. Now, metals extraction methods, if I talk about, they vary according to the reactivity series again. Like least reactive metals, they are easier to extract, and more reactive metals, they require a complex techniques, because more reactive means that they are going to have the high percentage of the impurities. But if I talk about the least reactive, they are going to have the more percentage of the impurity. So, extraction methods, if I talk about, we have again based on the reactivity series, that is potassium, sodium, calcium, magnesium, aluminum. So, these are more reactive than the carbon. So, they are going to get extract with the help of what? By the electrolysis method. Whereas zinc, iron, tin, lead, they are less reactive than the carbon. So, they are going to be the extracted by the reduction method, carbon extracted by the reduction. And copper, silver, gold, platinum, they are below than the hydrogen, so they are going to be very unreactive. So, they are found in their native state. So, if you are going to have the highly reactive metal, then electrolysis of their molten chlorides or oxides takes place. For example, sodium is extracted by electrolysis of molten NaCl, that is sodium chloride. So, if you are going to apply a electrolysis method, you are going to get a sodium ion and the chloride ion. Then reduction with the carbon, that is for the moderately reactive metals. So, iron is extracted from iron oxide using coke. So, like the Fe2O3 plus carbon monoxide is going to give you the Fe and CO2. And this is the very common question which is being asked again and again in exams. Then low reactive metal, that is by the smelting with carbon or electrolysis of ores, like copper is extracted from the copper sulfide ores, like Cu2S plus O2 gives you copper and SO2. Extraction of iron. Iron is the second most common metal in the earth's crust, is mainly extracted from the hematite ore, and this extraction process involves a series of reaction in the blast furnace. Like over here, I have shown the few reactions in the case of the iron, like combustion of the coke. Combustion means that you are taking a coke and you are burning it in the presence of the oxygen. Then decomposition of the limestone. So it is going to provide you the calcium oxide and carbon dioxide. Then reduction of the carbon dioxide. Then it is going to convert into a carbon monoxide, and that carbon monoxide is going to reduce the iron oxide. Now, in this extraction, we get a removal of the impurities, that is the sand or silica removal. So, limestone undergoes a thermal decomposition to produce the calcium oxide and the carbon dioxide. Now, from this particular part, we get a question, that is the slag. That what is the slag? So, basically what happens, that formation, the calcium oxide reacts with silica to form the calcium silicate and that is a slag. So now how we are going to get it? We are going to get it by the calcium oxide and silicon oxide. So use of slag is what? That molten calcium silicate slag, it is less dense than iron, so floats on the top of the molten iron and is tapped off separately. So it solidifies into a useful material for the construction. Aluminium is the second most used metal after the iron. So it is extracted from the bauxite, which contains impurities like the iron oxide, sand, giving it a red-brown color. And the major ore of aluminium is bauxite, which usually contains the iron oxide. That is why its color is going to be brown. So like over here, electrolysis method is going to do for the aluminium. So it is going to reduce at the cathode, forming the liquid aluminium. Then oxides are oxidized at the anodes, forming the oxygen gas. And then finally, oxygen reacts with the carbon anodes, so producing the carbon dioxide. Now, this was all about this particular chapter from where we get a question. So, let's see the type of the question so that roughly you will get an idea that what all type of the questions you are going to get to. So, over here, because from this particular chapter in one paper only, we get at least 4 questions. So, I have just covered the 2024 year only. So, let's see the questions. A company needs a metal with a low density which resists corrosion and is a good electrical conductor. Which metal should it use? Straight away it is aluminium. It is having the low density also, resistant to the corrosion also, and it is a good electrical conductor also. Okay. Next question. Next question says, which statement about stainless steel is correct? Now look, this also from the February-March series only. Now all atoms in stainless steel are in the same size. So this is wrong. Why? Because they could not have the same size. Reason being that stainless steel is what? It is the alloy. And alloy, you know that it is a homogeneous mixture of the metals. Then stainless steel is a mixture of the copper and zinc. Yes, this is correct statement. Stainless steel is an iron compound. This is not a compound, this is the alloy. Then stainless steel is stronger than pure iron. So basically over here, it is stronger of course, but over here it is a, sorry, I just miss out over here one word, so sorry. That is over here it is written a mixture of the copper and zinc. Okay, so yes, this is only the correct statement. Coming to the next question. Next question is, which statement explains why a water tap made of steel is electroplated with copper? Now look, basically we do a electroplating in order to remove its appearance. The first motive. So it is saying it improves the conductivity of the tap. So we do not require any conductivity for the tap. It improves the tap's resistance to corrosion. So yes, and it increases the density of the tap. So over here we do not require to do anything with the density also. So only option C, that is only statement 2 is going to be our answer. Now over here the table shows the result of separately heating 4 metals with oxides of different metals. The 4 metals are iron, copper, magnesium and Y. So over here it means, now look over here, the magnesium oxide and the Y oxide, over here iron is able to react with copper oxide only. Okay. Copper is not able to react with anyone. So copper over here is going to be the least reactive. And if you look magnesium, magnesium is able to react with most of them except the magnesium oxide. So it is going to be the most reactive. And Y is going to be at the second number and iron is going to be at the over here. It is reacting with the copper oxide only. So let's see. Now the question is saying what is the order of reactivity of the metals, the least reactive first and the most one. So magnesium is going to be the most reactive. This is correct. Copper is going to be the least reactive and then Y and then iron. So option D is going to be the correct answer. Coming to the next, which metal is most easily obtained from its ore? So it is the iron. Next, in the blast furnace, the impurity silicon 4 oxide is removed by the formation of the slag. Which equation represents the formation of the substance which reacts with the silicon 4 oxide to form the slag? So, basically it was the calcium oxide. So, option C is going to be your answer. Next, aluminium is extracted from bauxite by electrolysis. Which statement is correct? Aluminium ions are oxidized to form the aluminium. The cathode has to be replaced regularly because it reacts with oxygen which is formed. Carbon dioxide is produced at the anode. Cryolite is added to remove the impurity. So basically aluminium is oxidized to form the aluminium, means aluminium ions are oxidized to give the aluminium. Then brass is an alloy that is formed from the copper and zinc. Which statement is correct? Brass, copper, zinc all conduct electricity. Yes. Brass is a compound of copper and zinc. No, it is not a compound, it is the alloy. Brass is harder than the zinc. This is also the correct. So first and third, so therefore option C is going to be the correct answer. Next is the equation for the reaction of metal M with aqueous zinc sulfate is shown. Which statement explains why metal M reacts with aqueous zinc sulfate? So now look, this metal M, when it is reacting with zinc sulfate, it is forming a MSO4. It means that this metal M is more reactive than zinc. And that is the reason that it is able to displace the zinc. So over here, zinc is less reactive than M because M is able to accept the electron to form the zinc ions. So it is not converting into the ions. Then zinc is powerful reducing agent than M. Zinc is more reactive than M because it can lose electrons more easily than M. Zinc ions can remove electrons and form M. So over here, if I look, we are getting the MSO4. Okay. So zinc is less reactive. Over here, this statement over here, it is correct. But M is able to accept the electrons from zinc ions. Yes. So option A is going to be correct. Next is iron rust but aluminium does not easily corrode. Which statement explains why aluminium does not easily corrode? Now basically aluminium is not easily corrode because it forms the oxide layer. So over here option D is going to be the correct answer. Coming to the next question, three metals L, M, N are added separately for the dilute HCl and cold water. So what is the reactivity of the metals? Now look, L forms the hydrogen but no reaction over here. M forms the hydrogen in both the cases and N gives no reaction. So this means that N is going to be the least reactive. M is going to be the most reactive, isn't it? So let's see over here. It is going to be N is going to be the least reactive and what it was M. Yes, M was the most reactive. So option C is going to be our answer. So are you looking the question which I was saying you that this pattern question comes, such patterns question comes over here. And if you are observing the year over here, I am just discussing the 2024 May, June and the February, March questions only, and each paper consists of at least 4 questions from this particular unit. Next is X is a shiny silver colored solid at room temperature and pressure. X is good conductor of heat and electricity when solid. Which statement about X is correct? Now it said when it is solid. So X is ionic compound. This is going to be wrong because ionic compound conduct electricity only in the molten or the aqueous state. Then X is metallic element or a non-metallic element. Then X is an alloy or a metallic element and alloy and non-metallic element. Now it is saying it is a good conductor of heat and electricity and it is having a shiny silver colored solid. So it is going to be a alloy or a metallic element. Then which element can be combined to produce an alloy? So over here, we know that copper and zinc we can combine to form the alloy. So option D only is going to be our correct answer. Then which statement about aluminium is correct? Aluminium is easy to extract from its ore because it is near the bottom of the reactivity series. Aluminium is formed when aluminium oxide is heated with carbon. Bauxite is an important ore of aluminium. This is the correct statement. Hematite is the ore for the iron, not the aluminium. Next is iron rust in the presence of oxygen and water. Which statements about the rusting of iron are correct? Anhydrous iron to oxide is produced when iron rust. Now when you are saying that it is rusting, it means we are not getting the anhydrous but we are getting a hydrated form. Iron rust more quickly when attached to the piece of zinc? No. Coating the iron with plastic prevents the iron from rusting? Yes. And iron loses electrons when it rusts. So basically option D, that is third and fourth, is going to be the correct answer. Next, four metals Q, R, S and T are each added to separate samples of the water, steam and dilute HCl. The results are Q, slow reaction, then with steam fast reaction and with acid fast reaction. R is having no reaction, it means it is going to be least, and T is fast reaction and explodes, so it is going to be the most. Okay, and in the case of the S, it is showing no reaction, very slow and slow. So it means T, Q, S, R should come. Let's see over here. Sorry, the question said to separate. Now, R is the least reactive metal. So, I just look over here. Yes, this is going to be the correct. T could be potassium because it was showing reaction with everyone. S is more reactive than Q and R. So, Q and R. S. So, no reaction. No, this is going to be the wrong statement. And metals react faster with steam than they react with the water. So, basically 1, 2, 4. So, option A is going to be the correct answer. Next is metal X acts as a sacrificial metal to prevent iron from corroding. Metal X does not act as a sacrificial metal to prevent aluminium from corroding. What is X? Now basically for sacrificial method we use a zinc and magnesium, but in the case of aluminium we do not use a magnesium. Then which equation represents the reduction of the compound found in hematite in the blast furnace? Now what is the meaning of the reduction? Reduction means the removal of the oxygen. Okay, so over here if you look, the equation D is going to be our answer because the carbon monoxide is converting into a carbon dioxide and it is making the iron oxide into the iron. So this was all about for today's this particular unit discussion. I hope you enjoyed the session also and learned the important topics over here of this particular chapter. I'm very sure that if you are going to focus on these important topics and practice the questions of these whatever the we are having the paper or the question discussion over here and whatever the paper previous year papers we have, it is going to be very easy to get a star in the chemistry. So for such more videos, just follow us and stay connected to us. Till then, goodbye.